This is part of our ongoing 10-speed automatic series, the advantages of, some of the many reasons why you may want to consider transplanting a Ford 10R80 or a GM 10L80 variant into your project car. The focus of this discussion is something that came up recently. We've had a couple of questions and I think it's really important. Actual shift times, and what we mean by that are shift completion times. From the time the controller commands a shift to the time the shift is actually completed. We hope that you'll find this interesting, especially as it relates to and compares to some older 4-speed units and even the 6R80. Carl's done some extensive research on this. He's been digging through data logs recently, which you'll see in another video if you'd like to check that out. But Carl, what's the general consensus? What have you been seeing as far as actual shift times with these 10-speed units and the Quick 10?
It's pretty straightforward with shift times. The actual time the shift is actively dropping RPM, it's almost completely a function of the ratio step. So if you're going between two ratios that are very close together, the shift will be quick because you're not dropping that much RPM. And if you're going between two ratios that are further apart, it will take longer. So the things that affect the shift duration are the shift firmness settings, or how quickly the transmission shifts and how harsh or smooth the shift is, as well as just the ratio difference between the previous and the new gear. So when you factor all that together, the 10-speed is kind of a winner in that category. Most 4-speed transmissions, shifts take 3 to 4/10 of a second stock. That's with a stock valve body. Most people modify the valve body in those transmissions.
Right.
Drill out orifices and speed up the shift.
I'm glad you brought that up because you mentioned shift firmness settings. That's something that's fully adjustable using our Quick 10 controller.
Yes, yeah, and if you'll reference the video linked in the description that you discussed earlier, you'll see that, and we describe how that works. But you essentially have control over shift firmness as a function of throttle position. So you can make the shifts really smooth at light throttle. You can make them harsh at full throttle. You have lots of latitude to control how that works and what it feels like under every condition.
Is it safe to say that these new clutch-to-clutch 10-speed autos, you don't need to modify the valve body?
The valve body in a 10-speed is really just a bunch of pressure regulators. There's no intelligence. There's nothing that controls shift timing, shift scheduling. Everything is totally done electronically. The valve body is literally just basically a hydraulic control module.
That's awesome. One less thing to do. One less thing to purchase. No need for a shift kit, so to speak.
No, the only time you'd want to modify, there is a recall fix for the GM 10-speed, the 10L80, the Gen 2 transmissions, which we've covered in another video that we're still editing. There is a fix for that problem and you can accomplish that, but generally you don't have to touch the valve body except to fix weaknesses. There's no shift quality improvements to be had in the valve body, just durability. Yeah, the 4-speeds stock were like 3 to 4/10 of a second, about 1/3 of a second for each shift. And the 1-2 would generally take longer because it's a bigger ratio jump than the 2-3 and 3-4.
Does that still hold true with the new 10 speeds? The 1-2 is going to be a little more?
Yeah, the 1-2 on the 10-speed is the widest ratio step in the 10-speed. However, it's closer than pretty much every 4-speed transmission and the 6-speeds as well. Ratio jump is, while it's big for the 10-speed, it's smaller than any other transmission out there, so it really isn't a problem. And those ratios are very, very low. Second gear is 2.985, first gear is 4.696 to be exact. With that kind of torque multiplication, the time in first gear is quick. I mean, in 60 feet, you're done with first gear, but you're also going like 30 miles an hour. So it's over very fast, but it's a very eventful, exciting first gear. And then you go to second gear, which is actually lower than most 4-speed's first gear. So the shift recovery is quick, even though that is the biggest jump. You don't really miss it. So going back to the 4-speeds for a minute though, with those transmissions, you know, people would mod the valve body and you can get shift times of like 0.15, 0.17 seconds. But those are very harsh shifts, and depending on what kind of traction you have, the vehicle might go sideways during some of those shifts. And that's an issue we have. The 1.2 and the 10-speed can be kind of spinny, for lack of a better word, as you'll notice in the other video.
Right.
But you can actually notch down the firmness to correct that problem and make up for that. In a way, it kind of helps because the tires finish the shift and you keep going. But if it's excessive, obviously, wheel spin means less acceleration overall.
And you've got some actual real numbers that you've pulled from real data from our test vehicles that we're going to get into shortly. But it sounds like you're saying the customer has quite a bit of control over how quickly or how firm a shift is through the Quick 10.
Exactly, yeah. So if you take the highest firmness you're willing to tolerate, that's going to be the quickest shift no matter what. And the shift times for that firmness will always be lower with the 10-speed because the ratios are closer. And of course, you know, some people might say, well, you've got more shifts, so won't that be more time spent shifting? But you're breaking it down into several shifts. You're going to be shifting roughly the same amount of time no matter which transmission you have and how close the ratios are. It's just a question of whether it'll be in 2 events or in 6 events.
Sure.
So they're roughly about half the time, you know, because the ratios are twice as close as most other transmissions.
And is it also it sounds to me like the advantage with these newer units is you have all the control electronically. So if you make an adjustment and you're not happy with it, you can go backwards.
Oh yeah.
Whereas if you wanted to gain a quick shift with some of the older units via hydraulic modifications or a shift kit, you're stuck with what you've got.
If you drill a hole out from a 1/16 of an inch to an 1/8 of an inch, it's kind of hard to put that back. You'd either have to solder it up or weld it up, and then the separator plate would probably warp. So
I think that's a huge advantage people need to be aware of, is the adjustability goes both ways. And unlike some of the older units and the methods that were used to gain quick shifts, they were irreversible unless you put a new valve body in or...
Exactly, yeah. And you know, with the 10R80, 10L80, you have full adjustability. That with the 6R80 you do as well. It's the same basic scheme. It's clutch to clutch. With the 4-speed transmissions, we have some control over that too, but it's more limited. It's not as direct. We control line pressure, and that inherently controls the shift firmness, but not 100% directly. But yeah, I'll cover some of the shift times you can expect from a 10R80 with some caveats. The 1-2 shift is generally about 1/4 of a second.
Okay.
That's if it's not spinning during the shift. If it spins during the 1-2 shift, the shift will complete in about 1/10 of a second, or 0.11, 0.12 seconds, and the tires will complete the shift. 2-3 is like 0.18, 3-4 is roughly 0.14, and then 6-7 is about 1/10 of a second, because that's a little bit bigger ratio step, not as big as the lower gears, but of the higher gears, that's the biggest one. And all the rest of the shifts are somewhere in the neighborhood of 40 to 50 milliseconds.
That's incredible. So the further you progress, the faster the shifts become.
Yeah. Oh yeah. So, you know, you're talking like 1/20th of a second or less for 4, 5, 5, 6. They're very close together, and things happen fast.
I'm just thinking, compare that to a standard manual transmission application. I mean,
Yeah, manual transmissions, it's probably a half a second. I mean, I've never data logged that, of course, but it's going to take longer unless you've got, some sort of really good crash box or
Right.
can shift clutchlessly. But if you have to take the power off during the shift, every shift with a manual transmission is going to set you back.
Right.
That's what people don't understand too, is with an automatic transmission, every shift sets you forward. It actually accelerates the car because now that's if the transmission shifts well, and clutch to clutch is very efficient. There's no drag. If you had a lot of overlap in an older 3 or 4 speed transmission, it's going to induce drag during the shift.
It's constant propulsion.
Yeah, with clutch to clutch 6 and 10 speeds, there is no drag during the shift. You're just basically taking that crankshaft inertia as you slow the engine down and putting it into the tires. And if you don't blow the tires off during the shift, it's going to move the car forward. So it's actually a positive thing. Each shift, the car picks up a little burst of acceleration normally. And instead of having, 3 bursts or 2 bursts of acceleration during a quarter-mile run, you've got 6.
Yeah.
Generally, because you can usually use 1st through 7th in the quarter mile. I mean, depending on gearing and other factors. So you can shift 6 times, so you've got 6 little charges forward during the pass.
What about normal driving?
Normal driving, roughly the same time, because light throttle, you've got less, the engine's turning slower, there's less RPM to drop, less inertia in the crankshaft to put out to the rear wheels. So that all is similar, and it all depends on firmness, really. If you want super soft shifts, they will be longer. If you want really quick shifts, they'll be shorter, and it's just a trade-off. At part throttle, it's a trade-off of comfort versus speed, but light throttle shifts can be smooth. There's no reason to make them harsh unless you're just trying to, because the bottom line is the clutches are operating in a fraction of their capacity at like 10 or 20% throttle. Mm-hmm. And you're not going to cook them. You're not going to hurt them. You can make the shift longer. And I don't know about everybody else, but my wife likes it better that way. So yeah, there's no harm in having, you can have super smooth part throttle shifts and have it really bang at full throttle, but bang at full throttle does, potentially beat up things in the drive line, the transmission.
Yeah.
And, if you're breaking the tires loose, that could actually be, in extreme cases, the car could go sideways and be hard to control. So, it's all a trade-off. But the bottom line is the time spent shifting in a clutch-to-clutch transmission is not wasted time. It's not like you're turning the engine off. With factory applications and torque management, it can be. And if you've got an engine that requires torque management, like 700 horsepower or more, you'll want to use torque management. So that is a factor. And if you're torque managing, that does come into play. And you'll create a compromise between wheel spin during the shift firmness, and getting it done quickly. And you have control over all those things, as you'll see in the data log video. The 10-speed shifts, are all pretty quick. 6R80, generally 1-2 without wheel spin would be about 0.3 of a second. 2-3 would be about 0.22 seconds. 3-4 roughly 0.12, and 4-5 probably closer to a tenth. I'm not sure you'd use that in the quarter mile. The 6R80 and 6L80 are unique. They use the Le Pelletier architecture. It's really like a 4R70W with a reduction planted on the front, and they're using all the clutch combinations. It's not based on the 4R70W, it's a ZF design, but it works very much like that. But the side effect of that architecture is there's no 1-to-1 gear. Like 7th gear in the 10-speed is 1-to-1.
True 1-to-1.
And when you watch the data log video, you'll see the input RPM, the engine RPM, the output RPM all converge in one line.
As they should.
Yeah, but that never happens in a 6R80 or a 6L80 because fourth gear is a slight underdrive and fifth gear is a slight overdrive.
Which
So,
makes them sort of aggravating on the dyno.
yeah, because on the dyno you usually want a 1-to-1. I mean, that's the gold standard because it's the less loss and the most comparable. But there's no way to do that in a 6-speed. So yeah, you're always, so in the drag strip, you might be able to get into that slight overdrive, which is like 0.85, I think. Or you might just have to finish in fourth gear, which is like 1.14, 1.13, something like that.
Yeah.
So yeah, it's a little weird in that respect. But if you add up all the shift times of these different transmissions with comparable shift quality, the numbers will all be about the same because you're spending the same amount of time dropping crankshaft RPM. That's really what the shift does. And there's other parts of the shift too, though. There's the actual, the shift time, what we call the inertial phase of the shift when you're taking the crankshaft inertia and unloading it on the car. But there's also setup time, which is primarily clutch fill. You've got to fill the oncoming clutch and get it ready to take power. And then the torque phase is where you move the power from that off-going clutch to the oncoming clutch, and it starts carrying the load. It carries the load with a lot of slip, and then inertial is where you get the slip down to 0 and finish.
And all of that happens in potentially as little as 1/10 of a second, depending on the shift.
No, that actually takes longer.
Okay.
That's more like a 1/4 second for the 10-speed. It's very transmission dependent. Most of the 10-speed shifts are somewhere around a 1/4 second, plus or minus, because they've optimized most of the clutch feed circuits in the 10-speed, so the fluid gets there as quickly as possible, shortest path, not a lot to fill. But other transmissions, not so much. The 6-speed took a little bit longer. Some of those were like 0.42 seconds, especially like the 3.4. That's a slow one in the 6R80.
Okay.
Yeah, so it's 0.42. Some of the 4-speeds are crazy long. I think I might be lying here, but I think the 4R70W 2-3 shift, if I remember correctly, is very long prep time. It's like 2/3 of a second.
Wow.
Because you've got two solenoids commanding the gears, and so usually you turn one on or turn one off to go up through the gears. But that 2-3 is kind of a long delay, and each transmission with the 4-speeds, one shift might take like 0.3 of a second, another one might take 0.6 seconds. It varies a lot with the 4-speeds. It's very, very different. The 10-speed, fairly consistent. And you're going to say, well, that delay's a problem, but it's not in auto mode because the controller knows what that delay is. It's actually very consistent from transmission to transmission, which was not true with the 4-speeds because different valve body modifications that different people did would affect the setup time. But on the 10-speeds, setup time is very consistent between shifts, and the 6-speeds somewhat, but it varies probably 0.2 of a second between lowest and highest. But in auto mode, we know that time, we account for that time, we schedule the shift, so the RPM at full throttle is right on time. We know if we need a shift at 6,000 RPM, we need to schedule it at 5,700. The controller does the math on the fly and knows how fast the vehicle is accelerating, how quickly the engine's picking up speed, and it slots it in at the correct time. And it's generally, as you'll see from that data log video that we mentioned,
It's dead on.
pretty much dead on. We had a problem with 1.2. 1.2 is always going to be the hardest because that's the most acceleration. The car is going to be more dynamic in 1.2.
Well, that just speaks to how sophisticated the Quick 10 is. Sorry to interrupt, but what you're basically saying is, unlike some other systems, the end user, the customer, doesn't have to compensate. In other words, I want it to shift at 6,000, but I have to set it at 5,700. The controller,
Yeah.
the controller's smart enough to do that for you.
Oh yeah, yeah. And with the 4-speeds, you know, you might have to set it your 2.3 at, you know, like 5,000.
That's a huge advantage.
Yeah, no, it is a huge advantage. It's much more consistent. But the only time you'll notice that delay is paddle shifting.
Okay.
If you paddle shift, the setup delay will be there. But most people probably won't notice a 1/4 second delay in paddle shifting. But like if they tried to paddle shift to 4-speed, they would notice like a 2/3 second delay. And it's kind of moot because most 4-speed transmissions, if you're in the drive shifter position, you get no engine braking in 1 or 2. In fact, the only way around that is to modify the valve body, and none of them will have engine braking in 1 or 2 in drive. So you either have to play with the shifter or mod the valve body somehow. I think there is a mod for 4L60E to give you engine braking in 1 and 2 while you're in drive, but it's not the default for any of the 4-speeds.
Well, it sounds like, beyond a shadow of a doubt, these new 10-speed autos, out of all the transmissions we support, they are the quickest shifting out of all of them.
Oh, absolutely.
I mean,
Absolutely.
considerably so.
And if you add up all the time for comparable shift firmness, the time will be about the same, even though there are more shifts, because you're spending less time shifting.
And you reminded me of something else. I mean, we touched on the fact that it's an advantage that the customer can control the firmness. You mentioned the wife-approved shifts, and I'm sure a lot of our customers, that's important to you also. Wouldn't the fact that you can have multiple calibrations stored in the controller, that would be a benefit? In other words, you could,
Oh, yeah.
you could have a firm table, and you could have a wife table, for lack of a
Oh,
better
no,
term.
yeah, definitely, yeah.
So I just want to remind folks of that. You don't have to constantly be dialing it back or dialing it forward. You can simply switch between tables.
No, you absolutely can. And you can create, you know, a drastic difference between the wife table and the regular table. I know what my wife table looks like.
And it may be a husband table in some instances.
Yeah.
We don't want to. We're not trying to.
Right? No, absolutely, yeah. Yeah, no, it definitely, it can, yeah, it can be a big difference. But the bottom line is, if you're doing that and you're going to have both, do all of your learning in the smooth table.
That's an important point.
Smooth shifts are fine control. It really, everything has to be, you know, it's much harder to make a smooth shift than a hard shift.
And by learning, what you mean is, after the initial installation, if you plan to have multiple tables, one soft, one hard, for example, for a simple example, start your initial driving and allow the controller to do its self-tuning and learning on the soft table.
Oh yeah, absolutely. And you can even disable learning in the harder table
Okay.
so it doesn't corrupt the soft shifts.
So that's the only caveat.
Yeah, so that's how you'd want to do that. And then the hard shifts, basically you're just increasing the ramp rate of the clutch applies. That's all you're doing.
That's a good tip. I think that's also included in our success sheet.
I think it is too.
We
yeah.
have that notated in other places, so don't feel like you have to remember that. But you've done a pretty excellent job. I know you spent a lot of time researching this. So these are exact numbers from real world examples and real vehicles that went down the road. So.
And these are kind of based on our default tunes. You know, if you make it firmer or softer, it will affect it. And, you know, honestly, in some of our vehicles, we'll probably soften up the 1-2 a little bit, because we were seeing a half second of wheel spin at the end of the 1-2, and we could have used that to move it forward rather than make smoke. Although we all like smoke, but
right,
yeah. Tire smoke's part of the deal, but yeah.
And if you check out Carl's data log video, he does a good job explaining that and pointing it out on the actual graph. It's kind of neat to see what it looks like on a graph.
If anybody has any other questions, you know, we're here to answer them. Or, you know, we might make more data log videos too if that's what people want to see, because we feel that's a big part of the product. We have basically 100 hertz data logging. Everything gets sent 100 times a second. So it's very high resolution. It's what we use for development. I mean, we provide the tool to you too, but we use that to make the product the best it can be, and it really is a nice feature.
Let me point out once again, apologies for the interruption, but would you agree that when you hear data logging, most people think EFI. You hear it all the time in the EFI world. Everybody understands how critical data logging is in EFI tuning.
Oh, absolutely, yeah.
It's just as critical and just as effective through our system in tuning the transmission, so think of it that way.